need the wallet pop up. So I will share my entire screen.
Right. The stage is yours, so you can start whenever you feel
Thank
ready.
you. So let me start with like an overview of the product that we're building. So our product, let me check. Um, do you see my screen now?
Yes, we see your screen.
Okay,
The-
great. So our product called KPass is a NFT that you keep in your crypto wallet. It is encrypted under your own private keys, and it's an account that you own uh, outright, and it contains your government ID. If you want, you can put anything in it that you like. And the good thing about it is that you can present whatever information you like to whatever party, and the counterparty is able to cryptographically validate the presented information. So today, um, I'll show you what we have been doing, and we ported our product KPass on Mina. Um, so to enable that, I mean, deploying on Mina is different than many other chains because to be able to deploy on Mina, we had to create our own services for offline storage. I'll demonstrate how they work, and then I'll just show you an app where I present my KPass to claim some rewards, and I'll explain why we need that. All right, so let me. So this is well. First of all, KimlikDAO is building a protocol using which you can create this um, digital ID. But to encourage the use of this ID, we also run a learn to earn campaign um, where we teach people things about crypto in general. Like, for instance, we have this article about Mina's Berkeley upgrade, and we give rewards to people. And whenever we give rewards, there has to be a Sybil detection mechanism because this is fully on chain. If you're handing out rewards on chain, then a single bot just may claim everything. So how do we ensure that each real person can have at most claim at most once? Using our KPass technology, people can prove to a ZK app or a smart contract that they have not claimed this reward before without revealing anything about themselves. This is where the zero knowledge proofs come in. So this is our like page of our learn to earn campaign. We have this article that's still under, like, we didn't prepare the article text itself, but the structure is there. So I think that for Mina Berkeley, we're probably going to give 5,000 Mina or 10,000 Mina. We haven't decided. And then we will run another article about like ZK apps that is going to be 10,000 Mina, I think. So when I go here, so what am I going to do? So this is an article that gives you the basics of Mina, how it works, how you can create a wallet, how you can fund it, and once you have funded, uh, it instructs you to interact with your first ZK app, which is our KPass minting app. And then once you have your KPass, you'll come back here, and then we'll actually make you interact with another ZK app, which is the reward distribution ZK app. And once you interact with it, you'll just present the 100% anonymous part of your KPass called the human ID in it. And this learn to earn contract will validate that I have not claimed this. I mean, accept and validate the proof that I have not claimed my reward before. And if the proof checks out, it will give me in this demo 10 Mina. So let's get started. Um, so actually, while I was talking, our contract compiled in the background in about 15 seconds. Um, so, so how like technical should I be? Like, do you want to see the code?
Yeah, please go through the code
Mhm.
because technical reviewers will go through your
Okay.
code. So yeah.
Okay. So the So our contract consists of two parts. First, we have like a library for anyone who wants to accept human ID, like the anonymous part of KPass. So that library is in our SDK. Let me start with it, and then I'll show you the exact contract that we are using here. It's called the learn to earn contract. So let's start with the library. Actually, I'm going to make the text a little bigger here. So it's called, so we created a zk a smart contract base class. Whenever you want to accept human ID, like for instance, if I'm creating a voting contract, I want to ensure that each real person has one voting right. I may use it for airdrops. I can use it for whenever I need Sybil resistance. And then if I need Sybil resistance, instead of extending the normal smart contract, I just need to extend our base class per human ID contract. And then this has accept human ID method. It will take a human ID and then insert it along with its Merkle tree witness, and it will insert in the Merkle tree if it is not already present. If it's already present, it's going to throw an error. And so also we are using our human ID v1 technology for our midpoint. So these human ID v1s, their correctness, I mean authenticity, is ensured by 3 signatures signed by the KimlikDAO network. So human ID v1 authenticity is not based on zero knowledge proofs yet. That's our human ID v2, which we'll do in the final milestone. So what this does is that given a human ID, it validates 3 of the signatures. I mean, let's go through the steps. We first ensure that this human ID is authentic. I mean, I can claim that my human ID is 5 and then prove to the contract that 5 did not claim any reward before, but I could, if I could write any number I want, then I could claim all the rewards, right? Like we need a way to ensure authenticity. In human ID v1, this is ensured by signatures. So we will verify Mina Schnorr, and we require 3 different signatures from our KimlikDAO network. And the second step is we want to ensure that, well, first of all, this human ID was not in the Merkle tree. And secondly, the given witness is a valid witness for when I make the insertion. And once it's done, oh, I'm sorry, this step is actually this. Okay, let me explain this. So our human IDs are long, like they are 255 bits long, like a Mina, as large as a Mina field. But we don't, for each specific campaign, we don't need that much address space. Like if I'm distributing a reward, I'm probably targeting like a few thousand people or maybe 10,000 people. So to make things fast, actually, when we accept human ID v1, we just look at the last 32 bits. This makes things way faster, and the collision probability is relatively low. So if there's a collision, like if me and some other person has a human ID that are exactly the same in the last 32 bits, then only one of us will be able to claim the reward. The other one will not be able to claim. And we do this to optimize things, to make things faster. But the probability of this happening is so low that this is good for us. Like think of our example, we are distributing 10,000 minas and giving 10 minas per person, so 1,000 people. So if you think about the birthday paradox, the probability of there being a collision of like 2 to 32, that it's just negligible. So that's why. So we ensure that the given human ID's last 32 bits agree with the 32-bit witness. So this we do this check, and then this one is actually doing the insertion, ensuring that it was not in the Merkle tree, and if it was not in the Merkle tree, insert it and then get the new root and set it to the state of the per human ID v1 contract. And then we emit an event that we have accepted. This is crucial because our KimlikDAO network listens to Mina network, and then each node individually updates. Well, each node individually keeps a Merkle tree for each zk app address, and when an event is emitted in the blockchain, adds that to the Merkle tree. Even though we have a service, it's important to understand this is fully trustless. Like I just get a hint from one of the KimlikDAO nodes, but they can never fool me. I mean, they may give me false data, then my transaction will not fail. I mean, will not go through. Even I don't even have to pay gas. Our wallet will tell me that it's not checking out. So if one node tries to fool me, I can just go to another node. I can never do an incorrect transaction. I can't be fooled into doing an incorrect transaction by any node. So this is because of how Merkle trees. I mean, it's not our new. There's nothing new that we did here, but these events are what we listen to in our KimlikDAO nodes. I'll show you our node implementations in a second. Okay, so this was the base human ID contract. Whenever I want to accept human ID, this is the class that I want to extend from instead of the regular smart contract. So let me now show you this particular zk app for the learn to earn campaign. It's going to be in our apps blog. So this is our learn to earn. So with this base class, it's really easy to take a human ID and validate it. So this is the entire implementation of our learn to earn campaign. The claim reward just gets the sender of this, and then each human ID is not just signed outright as authentic, but is signed for use of a particular address. Like think of a driver's license. It doesn't say holder of this license is able to drive. It says the holder of this license with the photo being equal to the one on the with the face being equal to the one in the photo is able to drive. So for instance, a driver's license is committed to a face. So if I drop it, the next person cannot just take it and use it. Likewise, our human IDs are not just signed outright. They're signed for a use of a particular wallet. So this is important because, like, especially in EVM chains, let's say, I just broadcast this transaction in the mempool, and somebody else can just take it and use my human ID. So because of that, we need to sign it for use of a particular address. We also do that on Mina. We didn't have to, but it's actually makes the contract faster this way. So we get the sender in an unconstrained way because we send the money to this address. Like I may try to fool the contract with a false sender, but then with a stolen human ID, but then the reward will go to the real owner of that human ID, even though they didn't claim. I just ended up paying somebody else's gas fee. So this is the entire implementation of the claim reward. We just accept human ID v1 and send them 10 Mina. So let me show you how it looks like on the blockchain. So it has just one state, which is the Merkle root, and we don't need anything else. And let's just go to one transaction. For instance, someone claimed and got 10 Minas. So the the state root was updated, and then we emitted an event that I mentioned, that the human ID 100 was inserted into the Merkle tree. So, okay, before I do the demo, let me just explain the last missing piece in the code, which was how we maintain, oh yeah, let me explain. So this is the contract, right? This is, but then I need to generate the proofs for each of these. When I want to call this method, I need to generate a proof showing that I have locally called this method, and then the Mina state change from this to that, and that I have followed this contract truthfully. So this proof is generated by this worker. So this worker, we just give the human ID to this worker, and this guy is responsible for fetching the witness from one of the KimlikDAO nodes. Again, like this fetched witness is trustless. I mean, the node may refuse to give me, and I'll go to the next node. I mean, we didn't implement that feature yet, but you can do that. So this will just call one of our nodes, and then ask for the witness for this particular insertion. Here, I mentioned that we are taking the last 32 bits of the human ID. So this contract, this worker starts like compiling the contract as soon as it loads, which is like the heaviest part. Is actually takes 20 seconds usually. And then when I click on this claim button, it will just start working on the proof for the claim reward method. And once it proves and generates the transaction, the proof, it will send it back to this page, and then we'll send it to Aura wallet to sign and broadcast to the network. Okay, 24 seconds. Okay, so let me show you the last piece, which is our nodes who listen to the Mina blockchain and update our Merkle trees. So we already have a distributed set of nodes. These are used for signing the human IDs, validating various ways of proving yourself, and keeping the encrypted data. I may encrypt my KPass and then ask the network to save this for me, because I may have a wallet that doesn't have storage in it, like MetaMask, or I just have multiple wallets and then I want to share this data among. So our network will do that. Okay, so here's the Mina service in our nodes. So it has two entry points, very simple. One of them is witness. You can ask for a witness. You have to provide the ZK app's address, and then the insertion index. I want to insert a human ID to this ZK app address, and then we'll just get the relevant, the Merkle tree for that particular ZK app address. Oh yeah, so here we are fetching the particular Merkle tree corresponding to ZK app, and then from that we just get the witness and then just send it back to the requesting app. So this is the part where the ZK app, like here, for instance, when I click claim, we will need the witness. We will ask one of the nodes, and the node will compute it and then send it back. And the second part is that this node is on every minute in our current implementation, checks the blockchain. If there are new events emitted, it will just figure out for which ZK app was this emitted, and then for that ZK app's Merkle tree do the insertion. Actually, in our current implementation, we have to give a list of ZK apps that it needs to monitor. But in our final implementation, we have found a way to just you can deploy your zk app, and our nodes will automatically figure it out and start listening. We will ensure that by in our events putting a unique ID like KimlikDAO insertion ID, which is going to be globally unique, and then our nodes will pick this up, and then whenever it sees this, it will consider that there's a human ID v1 contract at that address. But for now, we just need to give the zk app list that it needs to monitor. So I mean, basically there are two types of events. When I look at the blockchain, there's one type of event which is the creation event. Like whenever there's a new per human ID v1 contract is deployed, we emit an event of type 1, and then when we see it, we just create a Merkle tree. This set height is essentially creating a new Merkle tree. And this second type of update is that a new human ID was added. And then we also add it to our Merkle tree here. So right now we are not reorg resistant, but we'll get to that. I mean, if there's a big reorg, this thing will not handle that well. But we have found a way to do it, not implemented yet. Okay, so this is basically the architecture. Now let's do the demo. Our contract is compiled. Now I have my human ID. I just want to send it and get my reward. Like prove to the contract that my human ID has not been used before, and the contract based off of that will give me 10 Minas. Oh, okay, I forgot to connect my wallet. So proving the transaction now takes about 15 seconds. So in the code, we are right now here. So we to the worker, we sent the human ID and it sent back the proof, and then we'll pass it to the Aura wallet to be signed and broadcasted. Yeah. Okay, so here is the transaction. It is sending 10 Minas out of the learn to earn contract and 10 Minas into my address, which is my address. And yeah, basically the only information that account updates are this. Let's confirm. Okay, so this is the transaction hash. It will take about 3 minutes for us to see it here, but okay, let me show you the code. Like, give me 3 more minutes, and then we'll see it here. So just to go over it again, when you want to accept the human ID v1, you just import our SDK and extend the per human ID v1 contract and simply call this method, just one method call. And so this worker, we don't have a standard way of doing it. We may include something in our SDK, but basically in what you need to do here is that get the contract, compile it, and then whenever you want to send the human ID, prove the necessary transaction, and here you can use our backend to get the witness. It's fully like distributed. both like geographically and ownership wise. So we have like right now, I believe 8 nodes in the KimlikDAO network, and each node itself is actually distributed because they use the Cloudflare durable object infrastructure. And also their owners are 8 different people. So we are both distributed in terms of ownership and geo. Let's see. Oh yeah, this is the one. So let's see what happened. So we inserted the human ID 101 here. This is the event 0, if you recall, was the insertion event, and this is the value, and the root was updated. And account updates are so, but yeah, we did account updates. I don't know where to see it here, but we did get 10 Mina, and then the zk app paid it out from its own address. So this is basically our demo, and let me know if you have any questions.
Thank you, Mert. Great presentation. Yeah. Any questions from the crowd? Okay, seems like not. Thanks again for your presentation and good luck. I'll stop the recording and start a new one for Kadirjan so that he can start. Yeah.
All right, thank you.